So this presentation will be held in English because of we are taking a film. So also the questions will be best doing it in English. And the purpose of the meetup is spread ideas, share ideas. We will share with you our journey, what the evolution of what we think we did. Basically, any questions, it will be better if it will be in the end of the meetup. A lot of topics, and short in So Kubernetes with testing Docker on Google Cloud. This is a name of the meetup. First, thank you for coming. Just from my personal interest, please raise your hands, the guy that is not from LivePerson. Okay. So this is question number one. Question number two, because I know the majority of LivePerson, please raise your hands. Also, the one who familiar with Docker, Kubernetes, the world of containers. Okay. So, as I said, thank you for coming. The first thing I want to make clear that what's in it for you, for here to spend your 1 hour, 1 and 10 minutes to listen to us. You will get some different approaches of how to scale automation or how to build automation in scale. The second, you will see how as clients we are using in technologies like Kubernetes, Docker, and Google Cloud Platform. Maybe, and the third, there's introduction of an open source called Ephemeral that will make an easy peasy way to launch a test at scale. So the meetup will be at two parts. The first part will be the decision we did, the journey we did. You will see the decisions along the way, and you will see two changes that happened along the way, and I will explain why we did it. The first part, as I said, decision. The second part is the new solution, which Waseem will present. Just to make clear that the second part is we'll talk about on any kind of test. It can be API, UI, mobile, Appium, you name it. It's supposed to solve it, but it should solve it. So let's get started. I want to introduce Waseem. If you can see, he's here. This is him running at England. Waseem is our senior developer, automation developer, tourism. You can find him at GitHub over there. So this is Waseem.
This is Arik, automation team lead at LivePerson. He has been in this position for 2.5 years. His hobby is also he likes to do private piloting. So have a safe flight with Arik during this presentation.
Okay. So a word about LivePerson. LivePerson transform connection between brands and consumers. Meaning, if you get inside a Microsoft website, you can get asked by banner, chat. It can be by messaging, via mobile, voice, any kind of interaction that can get the brand and the consumer together. A bit about LivePerson scale, about 2 petabytes of data per year. Around 3 billion visits a month, so we are definitely a big data company. Also using a wide variety of technologies for big data. And this is about 20 seconds, 30 seconds about LivePerson. Now, I thought how to start the meetup and how to start connecting you to what we did, because jumping straight to the technologies, jumping straight to what we did, I need to connect you. So we start with a short story about LivePerson deployments, how we deploy. LivePerson is a microservices. We have over 200 services in LivePerson. We deploy it in several data centers, Sydney, UK, US, Melbourne. And after each deployment, we have a team called UAT, User Acceptance Test, that every deployment check it manually. Now, this is a great pain because, not a great, it's a very big pain. And we have requested to automate this set of sanity tests that this team is running every day, each time they deploy to production any kind of deployment. So when we requested to automate such tests, we meet these requirements, meaning it's very different from a Scrum, from a dev, when you need to create your tests, you check your build, you check your release, and okay, it can run for 7 hours at night, it can run for 2 hours after we finish our work. We came in the morning and we have a green build. No, here we need to know, we need the fast feedback now, meaning after we deploy, maybe after 30 minutes there is a possible a bug or something, or a service interruption for a customer or a consumer. So we need to know it in 5 to 10 minutes. So this is the wish list. This is our requirements. We had a set of requirements for a fast feedback. As I said, we were running a sanity test for dozens of tests, and we need to know it till 5 to 10 minutes, no matter how much test we we develop. We needed to be stable. We needed investigation tools. Now, investigation tools, it's we need to think about it because we need to ask ourselves who is our clients. Meaning, if I'm in a dev team, in dev scrum, I'm developing my test, don't need an investigation tool. I know it myself. When my clients are support, SES, NOC, production specialists that using my test to check it, I cannot give them, okay, exception and good luck. I need to give them something to identify the problem. So video is crucial, not screenshot, not, okay, this screenshot or that screenshot, doesn't help. They want to know what happened during the test. They want to know what we did. I forgot to tell you that it is a UI-based. It has to be a UI-based because we are checking user behavior. And also, we want to provide them the HTTP archive. When the test is running, we need to fetch all the network during the test and understand where is the problem. So, as we see here, a large variety of requirements. So, we will start with a simple solution that most companies I know using the traditional solution. This is the traditional solution. Not sure how many of you know Selenium Grid. Maybe raise your hands, and anyone that heard it, right? The concept is simple. You need browser diversity. You need operation system diversity. You need parallelism. Now, most company uses static VMs, Windows machines. So we will start with this concept and move forward. So we have the hub, we have the nodes, meaning the hub is the manager. You manage it, you get the request, which browser, Firefox, Chrome, you get it. You take the request and put it on the node. The node raise up the browser and start the test. You can run it from Jenkins, TeamCity, it doesn't really matter. But this is a simple concept. Static VMs, Linux, Windows, and our requirements, it's answer the browser diversity, mobile, it also support mobile, parallelism. But the issues we faced, and the ranking, like I did it, because I compare it to another thing. Maybe someone else make it 5 stars, but this is our ranking. Let's talk a bit about stability. There is crashes, nodes crashing. It's a sickness of a Selenium grid. It's well known in the community. There's many solutions to it, Selenium extras or other solutions for automatic restarts, meaning for if a node crash, there is like automatic restart that can launch it back. But you need to ask yourself, like, I'm looking at it like I'm building a system. I'm building an application. Is my application going to rely, its stability going to rely on automatic restarts? Like, not sure about you, but for me, it's not really good enough. About tooling, we need a recording video isolated per each test. Meaning, if I'm using Windows machines, maybe there is some solutions, but many browsers open up. I need it to be specific. I need it to be isolated, not interfere to one another. Everyone talking about microservices, so we are looking at it also as microservice. I'm not going to talk. I think scale and fast feedback is the obvious, because how can I scale? I need to add another machine, add another machine, add another node, configure it. So it doesn't really meet up in the requirements I needed. So we needed a change. This is the first change, and I asked at the beginning to understand how many nodes, those technologies, to understand how much time I need to focus on a slide. So I will try to do it fast. So when you usually explain the differences, you know what, I will say it in this way. Cattle versus pets. If you have a pet, you regularly used to nurse him. If he gets ill, you nurse him until he gets back to health. He stays with you a long time. You name him. So if you are talking about a cattle, they're almost identical to one another. If one of them dies, you can get another one. So the versus between cattle and pets, like it's like VM and container. So if we are talking about containers, and we will get to the main idea in a couple of slides, let's talk about what a container gives us. So what we need is a resource isolation, test isolation from the automation perspective. Build it once, run it everywhere. Like when I tried to do it myself the first time, I built up an image. Then we'll talk about later on about images, but I built up an image, went to another machine, downloaded the Docker, launched it, and then I did it in another machine. It was like, it was really a great thing. Instead of getting up inside the Linux machine and configuring the things I needed, it was really like a work process changer, you know. So what we need inside a container. We have a container, if we are talking test-wise, or remind you our sanity test, our UI, user behavior sanity test, that we need to run it. We need a browser. We need browser, it doesn't matter, Firefox, Chrome. VNC server for recording. jar for standalone, hub, node, can be each one of the images. And about mobile, we will talk about it in the second part, about what we needed. So this is the very basic container that is needed for, if I'm talking about test-wise. So let's talk about the makeover. The makeover we did, we are talking about a hub Docker image. We are talking about no Docker image, like it's a separate images. Instead of running everything inside a VM, shared resources, VM like actually take the resource from the physical one. Container is only limited. So we got a different approach. We have hub, we have nodes, we have an army of nodes. Now, when I get an image, I can launch it, how many that I want. So this is the makeover architecture for Selenium Grid that we did. I will, in 2 slides, I will show, in several slides, I will show some demos. We took it, Selenium community have Docker images that is already built and verified. And you can download it, you can play with it, and start your own hub. And we are published this presentation, so you can get the link also. So let's see a quick demo. Okay, what you're gonna see now, I get inside the community, the Selenium community, pulling down the image that I want. It's really very easy. We can see here the Docker file, very simple Docker file, exposing the port that I need, environment variables like properties that I want to pass, very simple one. Download Docker. After downloading it, you can pull it out. I did it before, so it already exists. But once you do it, you can launch it with the port that we expose. Now it's on. That's it. You have a connected hub, ready to go, ready to get to the nodes. So let's go back to the presentation. So we talked about Docker. We saw a really simple one, how you get to the community, pull out, launch it, and you have a hub in an instance. But it's really nice. You can replicate it. I did it myself. I had 8 machines. Put Dockers in each of the machines, launch the Docker, launch the hub and the nodes connected. But I have a problem. I have a huge problem because I needed to manage it myself. I access to the nodes, I access to the machines, but I need someone to manage it for me, someone to manage the replicas for me instead of me doing it. So let's get to know a bit about Kubernetes orchestrator. Outside in the community, there is several solutions, maybe Swarm. I don't really know Swarm, but there is several managers. This is one of them. When we pull out, when we launch a container, it's not enough. We need several things. We need self-healing. We need, if I'm killing a pod or something happened to the pod, I need an auto restart, maybe auto replication, and scaling down, scaling up. I need it like in a click of a button. I need health checks. I need to know when my service is ready to go. And there is many other features that Kubernetes give me, like scheduling, etc. But for my purpose here, I decided to show the exact things that I need. So with our new manager and our new makeover, now we have Kubernetes cluster. We have a Jenkins that communicate with the hub and the nodes. That manage it for me instead of me doing it myself. So, okay, couple of things. So we have a Kubernetes cluster, but we still have some pains for our requirements, meaning in my requirements, I needed to run in geolocation, meaning I wanted to run not from Israel or Tel Aviv to sample my data center. I wanted to run from Sydney. I wanted to run from UK. I wanted to run it from US. And this is a very crucial requirement. About networking, here, if I'm running it inside my network, any network maintenance, any downtime in my in LivePerson network, I have also downtime in my tests. And these kind of things are really crucial for us, and that's why we decided to go to the cloud. We decided to go to the cloud also because of the idle machines, meaning, let's say we have a Kubernetes cluster. Here in LivePerson, we have we have a Kubernetes cluster in QA and in production, but my tests are the purpose is to do what they need to do and to die. Then I didn't need the machines, like it's a money spender. So instead of spending money, why not saving money? So our benefits from going to the cloud, as I said, Kubernetes in a click of a button. I'm not sure about all companies, but not in all companies, Kubernetes is a standard. I mean, here we have a DevOps, we have someone to go to if we don't understand something. But not all companies have Kubernetes standard. In Google Cloud Platform, in a click of a button, I don't need to be a Kubernetes specialist to get my things done. So it's a huge benefit. No idle machines, and we will show it in the next slide is the demo. I will show it. No need for idle machines. I did what I needed to do, and that's it. I killed it. Measure. Now I can measure how much my test cost. When I have 8 VMs, they give me 6 giga memory, 4 CPU, running it, not running it. I can't really measure how much it costs. Here I can cost exactly how much my test, can measure everything. About the network, we already talked about, and the geolocation. The geolocation, as I said, it's very important for what we need and our requirement. So let's see our first demo. Okay. So what we will see here is Google Cloud and the cluster. We are in Google Cloud. We, in a minute, get into inside the cluster that we did. Also, in a click of a button, a container engine. In the container engine, we will be able to see the auto-scaling is on. Now, okay, let's move it forward. What we can see here is what is running at the moment. We have a hub running, as we can see it. A service also we expose external IP. This is the hub. It's currently no nodes connected to it. So what we want to do now is launch our nodes. So let's take a look at the YAML, configuration. The way you deploy into Kubernetes is by, it's not the only way, because on the next part we will show a different way. But here, we do it in a YAML configuration, a replication controller which manage all the pods. Pod is a container or set of containers. So what we can see is a replication controller. I have 10 replicas, as you can see here. You can do it like 20, doesn't matter. Here's the image from the repository. We took it from, we insert it into Google Cloud repository. And we now limit it to 1 CPU, 1 giga memory. We know this is what we need to launch this node. This is the minimum, meaning, and then I can calculate how many machines I need. So let's launch it. What I'm doing now, I'm creating the file and launching it. Okay. So once we launch it, we also take a look inside the Kubernetes cluster. And what we will be able to see, the running, the pending, meaning the pending, like maybe there is no enough resources for all the pods or containers to launch up. So first, we can see in the hub, 2 is launched up out of 10. Let's see how is our machine. We have also 3 machines. See, didn't do anything, didn't configure anything. The auto scaling was up, and it's up to 3. Okay. What I didn't say is that my next demo will show what happened after 7 to 8 minutes. I didn't want to waste your time and to wait until everything is connected, because these pending containers, they need to connect to the hub. Imagine you have like 30 of them. How much time you need your build to wait until the node will be connected to the hub? It will take a long time. Meaning by long, minutes for me, it's a long time. So where is... This is a glitch for some reason. Okay. Okay. So let's see the second demo. Wait a second. Okay, got it. So as we can see, it jumps to 4. This is what it needed to launch all these containers. Now, when we see what we have in the classes, everything is running. All pods, container are running. We have the replication controller, the hub, and the Firefox 10. And now we can see we have 10 of them. It took about 7 to 8 minutes for this to be connected. Imagine that I have a build, I have a like test that needs like about 50 or 60, maybe 70 nodes. So it takes a lot of time. Okay. So let's talk a bit about the build lifecycle. This is our inspiration about our lifecycle, how it's going to be. Scale out, set up the grid, test it, kill the grid by killing its namespace, scale down, and repeat it. This is like our lifecycle in a Google platform. The requirements. So you'll see it's much better requirements than before, but issues. When talk about tools, also there is solutions for Selenium. There is plugins that gave us a solution for recording, but still, at the moment of truth, when the build failed, there's several recording that we didn't get. This means that we need to download open source and code ourselves to be resilient. Fast feedback, it's still, as I thought, it's a real improvement, but until the node will be connected to the hub, it takes a long time. Also, as you see, each image has its own browser version. That's the meaning of it, that we need to workload the hub. We have an image of Firefox version 47, and we need the Chrome. We need another image to connect to the hub. It's a still workload. Unless you do it in the same image, and then your image gets bigger. So you have also some facing issues with the browser diversity. And it's a multiple point of failure. Meaning, it's not enough that I have my build, I have my tests, I have Google Cloud, I have Kubernetes, now I have a hub and a node. Something went wrong here and there. It's a really multiple point of failures. And once again, we needed a change. So please welcome Waseem. We'll talk about thank you.
Okay, so this time we want to explore a solution which is not based on grid. Since our grid setup began to be more complex and more hard to maintain. As you might know, Selenium server can run in 3 different modes. Part of a grid, and also as a standalone server, not being part of a Selenium grid setup. So instead of the with the hub and the hub communicating with the node, in the standalone mode, the tests communicate directly with the node without having this hub proxy in the middle. So we took this standalone approach and combined it also with the containers and Kubernetes solution, and came up with a scalable solution for testing without using grid. We took the attributes of containers. First, containers are fast. It takes a couple of seconds until I have a running container with all its installation and all the processes running inside it. So I can basically, once the test want a new browser session from any browser version, I can basically deploy a standalone container of Selenium with the appropriate browser installation, and it's to maintain and set up the grid before. Also, one key attribute of containers that they were built to be short-lived. So basically, I can, once the test ends, I can destroy the container and keep my environment clean and stable. And I can also leverage the usage of Kubernetes and let all these containers be distributed and managed by Kubernetes inside my cluster over Google Cloud Platform or any other cloud or local or on-premise solution. So basically, once my tests want to initiate a new session, it asks for a new container deployment inside Kubernetes with the desired capabilities that it wants, according to the browser version, browser type. And Kubernetes, in turn, will deploy this container and return and expose an external endpoint inside the container with the IP and the port that it is exposed externally. And the test will initialize the new instance based on this external endpoint. We have one issue left with this solution. How can I let my test communicate with the Kubernetes cluster? And see, I need some sort of communication method or API which allow my tests to ask for a new container deployment, get the new remote WebDriver session, and also ask at the end of the test to kill this container deployment. For this purpose, we have developed an open source a Java library for creating short-lived testing endpoints over Kubernetes or any container clusters. And in our case, the testing endpoints here are basically the Selenium server endpoint. So in this case, let's say I have a large test suite which demands a lot of browser sessions initiated at the same time. Each test can basically connect to the Ephemeral API, ask for and pass also the desired capabilities that it wants from the remote WebDriver, and the Ephemeral API in turn will ask Kubernetes for to deploy a new Docker image with the appropriate image version and type. And meanwhile, our API will continuously pull Kubernetes to see if the endpoint is all ready. And once the endpoint is ready, our test will be able to initialize its browser session according to the readiness of this endpoint, which is Selenium server. Here's a simple snippet of JUnit integration of Ephemeral API into a JUnit test. As you can see here, we have defined the deployment context of our Selenium Ephemeral instance. We have defined which browser we want to use, if we want video recording or not. And here we build our instance. And once the test begins, it asks for the resource. And once it will be deployed and ready, the remote WebDriver will point to the container inside Kubernetes. Let's see a demo of how it works with Kubernetes. Okay, I've already prepared a test which can launch 10 ephemeral instances at the same time of different browsers, including Chrome and Firefox. And at the end of the test, it will also go over all the instances we have deployed and also destroy them. So let's begin with the test. I will forward a little bit since I don't want to explain about the test code. Okay, so here, as you can see, this is the Kubernetes dashboard, including all the workloads that it now has. As you can see, we have an empty workload without any deployed containers. Once we run the test, here we can see how Ephemeral library is deploying all the containers inside the Kubernetes. And it also pulls the status of the deployment. Our desired status is finished, but some of the deployments are still in progress. And here we can see how Ephemeral is fetching the endpoints that were exposed inside the containers. And in our case, it's the remote WebDriver URL. And it also checks if the endpoint is reachable. As you can see, some of the endpoints are reachable. So if you refresh the Kubernetes dashboard after running the test, we can see how it spins for us 10 instances of different browsers at the same time in a click of a button. We have instances of Firefox and Chrome. I want to remind you that we didn't set up any grid beforehand. We came with a bare-bone Kubernetes cluster without any defining any grid before. As you can see, I can also access the currently deployed containers and see the log of what is running inside the tests. As you can see here, it's doing some remote WebDriver API calls to find elements on the website. And here, after the test finish, we can see how the Ephemeral API will ask Kubernetes to delete and destroy all the deployment of the containers that we have deployed. And in a matter of seconds, we will see how our Kubernetes cluster is back to its initial state. Okay, here's the demo we have presented. Okay, now let's move from web-based testing to mobile testing using Android and Appium. We're all aware of that challenges of running mobile tests with Appium and Android and maintaining all the mobile test environment, including Appium crashes, which we have to handle, and handling multiple Android SDK environment installation and maintenance. Also finding the perfect combination of the Appium and WebDriver API version compatibility. And most importantly, it's very difficult to do mobile tests in parallel. We have to manage the binding of the Appium server with the device ID. You have many devices. You have to launch multiple Appium servers and bind each Appium server to each Android emulator, and it becomes very difficult to do in parallel. And I don't want to think about scaling my mobile tests if I can't run them in parallel. But with Ephemeral, actually, things get much easier. Since I can wrap the Appium server and the other emulator inside an isolated unit, so they can communicate internally. So I don't have to deal with the binding of the Appium server with the appropriate device ID, since they communicate internally. So I can basically duplicate these containers as much as I want, and I can let them scale according to the capacity of my cluster. If I have enough capacity inside my cluster, I can basically create how much mobile Appium server and emulators at the same time and let them run in parallel. And this way, the Ephemeral API will also pull Kubernetes for checking once the Appium server endpoint is ready. And once it's ready, the test will get back an instance of the Android driver with the Appium IP and port that it got from the API. Okay, let's see a short demo of how it works also on Kubernetes.
Do you run also iOS simulators?
No, iOS simulators with GCP we don't have Mac instances, VMs, so we're not able to run iOS. But for Android, it's a pretty good solution. Okay, let's see a demo of Appium. You can see a test which basically initialize an Android driver according to the ZAR capabilities that we have defined. We have defined here an Android SDK of version 4.4, and we want to install the contact manager APK inside the emulator, and we'll basically do a simple test which will access the contact manager app inside the mobile and click on that contact in order to add a new contact. Here we define the ephemeral instance of the Android type with a ZAR. Get method will deploy instance Kubernetes and the Android driver as we showed earlier in the previous diagram. Okay. Here we run the test. As you can see, the Kubernetes dashboard workload is empty. Here the Appium instance is being launched. So you can see how it's pulling the image and starting the container with Appium server and the emulator. Here is pulling and see if the emulator and the Appium server are ready. And in a couple of seconds, we will have a ready Android emulator which we can use, which is basically running on GCP and Kubernetes. Now, here we can see how it accesses the contact manager. Click on the add contact. And once the test finish, it will also destroy the container in GCP. And again, we have a clean environment after the test finish. Okay, so now let's rewind the requirement and see how our new solution, we can see how it fulfilled all the requirements that we needed from our test infrastructure, including stable environment, isolation using Docker containers, scale using Kubernetes, browser diversity by ditching all the grid-based solution, and also mobile support by using images built for Appium and Android. Okay, now let's talk a little bit about beyond UI testing and mobile testing with Appium and Selenium. We can basically use Ephemeral to deploy any test dependency inside a container, including web servers, Nginx, temporary databases such as MySQL, mock servers, including mock, or any other Docker image, or any other test dependency which can run inside the Docker image. So if you want to set up a complex environment for our integration or end-to-end test, we can basically deploy each unit of this environment inside a container and simulate a complex test environment very easily. Okay, let's see, for example, a real-world example of how we can combine different short-lived instances of Docker containers using our library. Let's say we want to do some UI tests in our web application using browser-based testing. We can basically deploy our web application inside an Nginx container, and let our ephemeral instance, which includes browser and Selenium, communicate the Nginx instance and do some UI testing. And we can also, and each endpoint here is what Kubernetes exposed for us from inside the container to its to outside. And also, if our web application uses some sort of backend to view some results, and the backend is not ready, we can create a mock server using WireMock, and also deploy it as a container, and basically let our web application communicate with the mock server that we have deployed. And this way, we have set up a pretty non-trivial test environment by using different instances of ephemeral objects in our tests.
All of them are orchestrated by the same Kubernetes?
Yes, by the same Kubernetes cluster. Okay, let's see. I'll try to see a demo of it in the code. Okay, as you can see here, we defined 3 JUnit rules. Each one defines a different ephemeral container which we want to use in our tests. The first one is Nginx, the third one is Selenium, and the third one is WireMock. And we also defined WireMock mock server with a JSON mapping, which includes what we want to, which request and response we want to mock. As you can see in the JSON file here. And our tests will approach the Nginx resource, which we have defined as a JUnit rule, fetch the Nginx web server URL endpoint, and let the Selenium instance communicate with the Nginx instance which they are deployed. And here we can see how we can use different instances at the same tests, so they can communicate with each other. Okay, future plans which we are planning to integrate inside our library is also provide a REST API, which will allow non-Java tests, non-JUnit tests, to also use the features that Ephemeral provide, and allow Java tests to also very easily as we do in our tests. And we also plan to provide support for more cluster management systems, including Mesos and Docker Swarm, in addition to Kubernetes, and also provide more modules which we will find useful in addition to our Nginx and WireMock and Selenium modules which are currently available. So our takeaways from all this talk that we did today is that we should continuously enhance the traditional tools that are available for testing and for web and UI testing. We also should use containerized environment for setting up our complex test environments, since they are short-lived and can be thrown away once the test ends. And this way we can keep our test environment stable, and we can also scale this test environment using container orchestration with Kubernetes and other cluster managements. And we also can benefit from testing on Google Cloud, on cloud platforms in general. And we already saw the benefits of running on cloud platform, as Arik showed earlier. And any questions? Yes.
Why are you doing it only for a post-release sanity? Are you planning on doing it also
Yeah.
for development testing?
So the question was why we are doing it only for post-deployment and not for many other teams.
Okay, we're planning also to integrate inside the development teams, but the post-deployment was our initial trial of this library. And we also, yes, we have plans to also integrate it as a test environment for other teams.
And if you do that, you're going to use your open source also to deploy the application themselves? This cluster?
We don't. I find the whole life cycle of how we'll do this, but we prefer to keep this open source only for testing purpose, not for the deployment itself.
We also have other teams that using it on a Kubernetes cluster, not on the cloud, on a QA environment that using it. We have already 2 or 3 teams, and it's starting to spread out.
Yes, but not for deployment of the application itself, but also.
The application themselves are not Docker images yet.
There are
Some of them.
LivePerson standard already started with Kubernetes and Docker. We started movement, each one of the application, and a new application born inside Docker and would run in Kubernetes. There was also Kubernetes cluster in production for LivePerson applications, but yeah. More questions?
Can you talk a little about why you chose Kubernetes over the alternatives and why you chose GCP over the alternatives?
Kubernetes, for the alternative, first, it is a LivePerson standard. It was really easy because we are in LivePerson. For a company that doesn't have any real standard, in Google Cloud Platform, it was really easy. Google Cloud and Kubernetes was born from Google, so it was a good.
They have a built-in support for building Kubernetes cluster in a minute.
Yeah, and for the cloud, we needed our purposes for geolocation. We don't want we can't run our test from here. As I said before, networking. We need to run our test from different kind of locations and not just from Tel Aviv. If you said why Google Cloud and not Azure or Amazon, can really give you a good reason, and except of Kubernetes made by Google, so we went to Google. Any other? Yes.
Is there a way to run the automation on Safari or Slow?
So the question.
There is a.
Let's repeat the question. The question was, can we run it over Safari and Explorer as well?
Okay, regarding IE, there is now an effort from Microsoft to also support containers and Docker, but still not very mature. So we don't have a solution for IE, and also for Safari we need Max, and Google has not provided instances of iOS yet, so we don't have also a solution. We currently support Phantom.js, Firefox, and Chrome from all the versions that it has.
we saw that in Google they provide instances for Windows. So I think in the future we will try maybe to launch maybe a container inside Windows that is part of Windows for Explorer, but we are not there yet. Yes.
Do you do A/B testing?
From our
From our side we don't do
From our
it.
side, we don't do A/B testing. Maybe inside the teams, I think they do. But again, this
The automation doesn't test the A/B testing.
no. Only user behavior for our purposes or our needs. What I think we need to take from what we saw here, that we show it on UI testing, but it doesn't have to be UI. It can be APIs. It doesn't matter what image you deploy to Kubernetes. So we have teams that have a build that's running with 300, 400 tests of APIs, and it takes about 2 hours to get a release. So I think it could be a good solution. Other questions?
How do you know how big my cluster should be?
You want to answer? That's,
There are many aspects which you have to define beforehand, and also Kubernetes provide, in GCP it's provide auto-scaler capability. So you can start with a small cluster, and it will auto-scale itself once it demands new deployments of new containers.
a bit of a secret about the auto-scaling, it's in beta. So we have two approaches, autoscaler, like automatic from Google Cloud, or doing it with G-Cloud with resizing your machines. So in this concept, you control the resize. When you start up, scale down the machines, scale out the machines, and then you control it instead of waiting a couple of minutes for this to happen. In this presentation, I saw the automatic. We also did the resize command line of G-Cloud. And in this, if you are using G-Cloud, you need to compute it. You need to calculate how many tests you run, get it, calculate it, and then I say, okay, I have 10 classes. From my experiences, I need 15 machines, so you scale out to EG's 15 machines.
Yeah. Are you using one cluster per suite, per test suite, or are you using one cluster for several suites? And if so, when you're polling for to get your resources from Kubernetes, how do you know that it's specific to that?
Which Kubernetes cluster you mean?
No, I mean if you, okay, that depends on the answer, but if you're using one cluster for several suites, or you're using...
So let's understand the first question, if we use those tests to several clusters.
Yeah.
Yes, so the answer is yes.
So it's one suite per cluster?
We have
one cluster per suite.
Yeah, it's a one suite per cluster, but we have a life cycle, meaning if my clients are support NOC, I don't want, they're using a cluster that is production.
Yeah.
And then we have a staging environment. Then we use our tests and see that like perfectly stable, or like at least a failure rate of 1%. Then we go into production. So yes, we are using several clusters with autoscaling. The second question?
So I guess it's a non-issue, but so then when you're calling to get your resources, you know it's yours because the cluster is only...
Yeah.
Yes. You can also use labeling of the
okay. So
deployment you do, so you can bind the deployment according to the label that you have set in your deployment.
Any more? Or I can release you.
Thank you.
Okay, thank you. Appreciate your time.